We hope you enjoy this free preview of our webinar, Leveraging Soil Survey for Wetland Delineation. Access to the full 2-hour webinar can be purchased at www.hammerenv.com.
Up to this point, we focused on how soil scientists predict soils across the landscape and then verify those predictions in the field. So the next step is, now that they have all this information, how is it organized and displayed so that people can actually use it? So there is a process in soil mapping called soil correlation. I want to try to make this intuitive. So I want you to think about walking through a farmer's market or the produce section of a grocery store. You'll see fruit that's grouped into categories. All the apples are in one section, the citrus is over here, the berries are over there, and then within each fruit group, let's say apple, citrus, and berries, you'll have varieties. For the apple bin, you might have Granny Smiths and Honey Crisp over here, and Gala apples here, and Yellow Delicious in this area. They're all different varieties, but they're together because they're all apples. They share enough key characteristics that grouping them together makes sense. So that idea and concept is how soil correlation works in a soil survey. So here's an important question to consider. How much separation can a soil scientist make on a soil survey? Can they only separate apples from citrus and berries, or can they separate individual varieties of each fruit group? Well, the answer is that soil scientists can do both. They absolutely have the technical ability to distinguish subtle differences between soils, what we're calling different like varieties of apple, citrus, or berries. The limitation is not the scientific skill. The real constraints on separation are mapping scale, the intended use of the map, the time that you have to do the map, and what are the available resources, mainly people and money. Under the scale and level of detail that is typical of most soil survey projects, soil scientists can reliably separate apples from citrus and berries. In other words, soils that look and behave very different from each other. What they usually cannot do in a typical soil survey is separate every individual variety. At best, a few of the most common or most distinctive varieties may be mapped separately. So that means that there must be soils that are different from each other that need to be intentionally grouped together. And this process is called soil correlation. The result of that process is what we call soil map units. Soil map units are not pure. They are deliberate, practical groupings that balance natural landscape variability with the need to produce information that is manageable, usable, and interpretable. The next sentence I'm going to say is really important to understand. Each soil map unit contains variability, but that variability is understood and predictable within the soil survey. However, this is often ignored or not understood by the user. So I want to dive deeper into this. So I want to move from the fruit analogy to the real thing. This is a picture of a soil survey out of Suffolk, Virginia. We have the map on the right and the legend on the left. First thing I want you to notice is that there is a map unit symbol and a map unit name that I've highlighted with a green box there. The map unit symbol is what you see on the soil map, and the map unit name tells you which soil dominates the area that's delineated by the lines on the map. So the dominant fruit variety in the bin, so to speak. All right, so when you see a symbol, like the one I have here, like 8A on a map, it consistently represents the same soil concept inside the City of Suffolk Soil Survey. It is an area that is dominated by a soil called Eunola, loamy fine sand, 0 to 2% slopes. So that means that most of the time when you see Eunola in Suffolk, in this map unit 8A, it's going to have a surface texture of loamy fine sand. Not always, but that's the dominant. 0 to 2% slopes. Not always, but that's the dominant slopes. So every time 8A appears in this survey, it tells the same basic story about expected soil behavior. So using our fruit analogy, think of Unola as an apple, and in this case, a gala apple. Right? The soil scientist knows there are other soil varieties out there, but at the scale of mapping, it isn't practical to separate out every variety. And so what they do is they choose what variety best represents the concept across the entire survey area. So if soils were apples, the soil scientist knows there are other apple varieties mixed in, but they choose which variety is the most common and best represents what's there. The same idea is true for soils. So within Map Unit 8A, soils like Slagle are minor components that are mixed in with Unola. In the field, Slagle looks very similar to Unola, and it behaves in a very similar fashion. So let's call Slagle a Red Delicious apple. So at this mapping scale, either the soil scientist doesn't have the time to make the separation, or separating them would add complexity without adding meaningful interpretive value. So they know there are galas and Red Delicious apples out there, but the gala dominates, and even though the Red Delicious is different, at the scale of mapping, it's not practical to separate it. So that's soil correlation in practice. Grouping soils that behave similarly into a single map unit while acknowledging and managing natural variability. Understanding this is what allows a soil map unit to function as a predictive tool for how the landscape works. So on this map, each 8A polygon highlighted in red, you can expect similar soil properties to dominate. So let's go back to our legend from Suffolk, and I'm still using the fruit analogy to help explain soil map units. So we are imagining that instead of soils, we're looking at a map of fruits. Unola soil is an apple, Lynchburg soil is a lemon, and Range is a blueberry. So I've highlighted all the Unola soil map units or apples in red, all of the Lynchburg soil map units or lemons in yellow, and all the Range soil map units or blueberries in our analogy in blue. So every time you see the same symbol, you can always expect to see a specific soil type. However, you need to know that not all polygons of the map units of Unola are the same. They are similar, but there is variability within each polygon. So soil map units aren't about perfection. They're about creating useful patterns from a complex landscape. So let's say you're running a transect across this large range soil map unit that's represented by blueberries. You're digging a hole everywhere there's an X. So the normal expectation is that, okay, I'm digging 5 holes in a map unit that's range, aka blueberry. When I dig holes, I'm going to see a blueberry every time I dig a hole. But then when you don't see a blueberry, when you dig something else, we often conclude, well, this map isn't any good. It's not a blueberry, and the map says it's supposed to be a blueberry. So let's examine and understand this at a deeper level to see if our expectations are wrong or if the map is wrong. So on this transect, we make 5 observations in the blueberry, aka Range map unit. So instead of 5 blueberries, I see 3 blueberries representing Range soil. I see 1 lemon representing Lynchburg, and I see a blackberry. Well, I didn't even expect that one, which represents Myatt soils. So what's up? Is this a good soil map or not? Okay. All right, so my transect shows 60% Range, 20% Lynchburg, and 20% Myatt. So now look at the yellow highlighted description from the soil survey. It states Range and similar soils make up 75% of this map unit. So here's a critical point that many people miss. That 75% isn't referring to the specific polygon that we did the transect in. Instead, it's the expected composition across all Range polygons throughout the entire Suffolk soil survey area. So now, how do our field observations stack up against the map unit description that the soil survey is telling us? All right, so what I want you to notice here is that for each soil map unit, the variability is different. So notice in red for the Unola map unit in Suffolk, it says that you can expect about 90% Unola and similar soils. For Lynchburg, that's highlighted in yellow, it says you can expect Lynchburg and similar soils at 80%. And then going back to our transect that we had in Rains, the map unit composition for Rains is 75% Rains and similar. So we had 3 blueberries and 1 blackberry. And because they're all berries, there's differences, but they're all berries, they got correlated together. So what we actually see here is, when we look at this composition, this is exactly what you would expect if you understand what the map unit composition is telling you. What the soil scientist said, this is not a pure unit. These are the variabilities that you can expect. And so this type of observation does not point to the idea that the soil map is wrong, but oftentimes it's our understanding of what's supposed to be there. When we see blueberries as the title of that map unit, we think everything should be a blueberry. But within the soil survey itself, it describes what that variability might be. All right, so let's take a little bit of a deeper dive into soil map units, and then we'll take a break and ask questions here in just a couple minutes.